Right, so here is our fourth sample problem, and here you can see that we're given four equations. So it's not much different from solving all the other ones. So first thing you do is look at what are your reactants, what are your products, and based on that you want to make changes according to what are your reactants and products. So first we look at the reactants. Reactants, we have C6H4O2, OH2, and H2O2. So let's look for those. So as you can see, we've got a C6H4OH2 on this side, so we're good for that. We don't have to change anything. That's great. And let's look for the H2O2. Well, it doesn't look like we've got anyone on this side, but we do have one over here. So how do we get it back to the reactant sides? Well, that's pretty easy. You just gotta flip. So we gotta flip this equation. So let me make a note of that. So we gotta flip that equation. Sorry, my bad handwriting. And when we flip that, we also have to flip the sign. So flip. Okay. So that's our reactant. So now let's look for the products. So we're looking for C6H4O2 and 2H2O. Well, not necessarily 2H2O yet, but just H2O in its liquid state. So do we have both on both sides? So we have the C6H4O2, that's good. And then do we have an H2O in its liquid state? Yes, we do actually. So we don't have to modify anything yet. So looking at these equations a bit longer, you notice that we have a 1/2 O2, which is really annoying when you're trying to add and subtract everything. So we're going to have to multiply this one by 2. So let's make a note of that. 2x multiply. And then when you do that to the equation, you also have to multiply this by 2 times. Okay, so now you have so just imagine in your head right now you have a theoretical 2 in front of your 2H2O, but we don't actually have a H2O in its gaseous state in our products. So we're going to have to get rid of this at some point. So how do we get rid of that? Well, we look at the other side. Does the other side have an 2H2O in its gaseous state? Well, we don't. So we got to do something, but we do have an H2O in its gaseous states on the reactant side. So what we're going to do here is multiply this by 2 as well. So in order to have these two cancel. So now with everything relatively balanced out, we can go ahead and do all of our so-called commands there, and everything should cancel out, but we'll see. Oh wait, and I forgot, gotta multiply this as well. Okay, so okay, so first step, you don't have to do anything to the first equation, so I'll just rewrite that. So the first equation, first equation is C6H4OH2 aqueous, which turns into C6H4O2 aqueous plus H2 gas. And then our heat of formation, well, that's going to be plus 177.4 kilojoules. Alright, so then we go ahead and transform, well, not transform, flip our second equation here. So we've got H2O2 on this side now, which is going to turn into H2 gaseous state plus, sorry about my bad handwriting, plus O2 gaseous state. So then when we flip the equation, we also have to flip the heat of formation, otherwise right now it's thinking it's an endothermic reaction, but since we flipped it, it's going to be an exothermic reaction. So now it has to be a plus 191.2 kilojoules. And then, as we look down, we see that we have to multiply our third equation by 2. So let me change my color real quick. Okay. So we have 2H2 gas plus O2. And remember, we're multiplying this by 2 because there's an ugly 1/2 right there, and we don't want that. As well as it's going to help us balance everything out later. And then we have a 2H2O. It's gaseous state. So since we multiplied this by 2, now we got to multiply that by 2. So okay. So we want to multiply negative 241.8 by 2. And then what do we get? Okay, we get negative 483.6 kilojoules. Okay, we don't need that for now. And then now we need, for the fourth equation. So for the fourth equation, we're also going to multiply by 2. And just to remind you, we're multiplying this by 2 because we need to cancel out the other stuff on the right side. More specifically, the 2H2O. So 2H2O liquid. So then once you multiply that, you also have to multiply this by 2. So grab out the calculator again. Clear, you have negative 43.8 multiplied by 2. So now you have 87.6 kilojoules. Alright, so sorry about the cramped spacing. So now I'm just gonna draw a line just to make it more clear. That's what. Sorry about that, guys. Okay. So what can we cancel out here now? Now we've got 2H2O here, 2H2O here. They're both in the gaseous state, so we can cancel that out. And then, this is a tricky one. So we have 2H2O. So where do we find that? So we have one here. The other one's actually over here. So cancel that, cancel that, cancel that one. Okay, so now we can cancel the O2 and the O2. So all that you're left, you should be left with the original equation. So let's see. C6H4 OH2 aqueous, which turns into C6H4 O2 aqueous. Oh, sorry, I'm too caught up in the moment. Let me just change that. Plus H2O2 aqueous, which turns into C6H4O2 aqueous, and then you have to add your 2H2O down there, 2H2O, and its liquid state. And then now you got to add up all of your heats of formation. So let's do that. Okay, so first you have 177.4 plus 191.2 plus, or actually minus, my bad, minus 483.6, and then minus another 87.6. And what would you get? You get negative, you get a heat of formation, which totals, oh, sorry. You get a heat of formation that should equal negative 202.6 kilojoules. Alright, and that's how you do this problem. Thanks.